Okay, and we're good to go. Now, just so you know, whenever you ask a question, it does not come up on the tape. Okay? You're not loud enough. So don't be embarrassed to ask questions. Remember, I get paid millions of dollars a year to answer your questions. So if you want me to take home a free paycheck, that's your, right? But you need to ask questions while you're not getting it. Is that a 3? Is that a 5? It's just a matter of putting up your hand. Don't yell out at me. You know, you have to have grace with me just like I have grace with you. I think when you say something and I say that's the stupidest answer I've ever heard, that's not grace, okay? That's like the opposite of grace, right? So you can't be rough on me either. Okay, so now we're starting with what we were working with all day yesterday when I was talking about the patterns on the island, the patterns when you were working on your puzzle. Okay, that was patterns, and you had to kind of articulate that in your head, right? Now, here is a tower made by playing cards. Okay, now right here, just so you can see, this was the first part of the tower. Now you're like, huh? He built it going downwards? Yes. Okay, so he built this where there's no gravity, and he built it under the table, so it's going down like this. Okay, so here's the table, and there's no gravity. Okay, and they say math isn't real. Now, how many cards were used to make row 1? 3. Okay, with me so far? How many cards were used to make row 2? Okay, count them up. How many cards? So, right, 1, 2, 3, 4, 5. Oop, no. 1, 2, 3, 4, 5, 6. Okay, so we're talking about new cards. 6 new were added, right? Because that bottom one was already there. Okay, how many cards were added for the next row? Added, so don't count the ones that have already been done. So maybe we'll do that in blue. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9, okay? Now, if you were to draw this out again, how many cards would you think would be in the 4th row? So 12, and how about the 5th row? 15, okay? See, what we're trying to do here is be efficient. One thing about 30-1, 30-2, I'm not just trying to teach the concept, I'm actually trying to be very efficient about it, okay? Now, some would say, hey, just throwing me in the canoe and me flying around, that's not very efficient. Well, sometimes there's a very good saying that, you know, you can't teach a learner till the learner is ready. And when a learner is ready, it's when they're going, how do you do this? Like some people just need to learn that way, right? Now, let's just look at the chart. We're going to put the same numbers in, right? 3, 6. The 3rd row, there was 9. The 4th row, there was 12. And the 5th row, there was 15. Okay, so can someone, just putting up your hand, tell me the rule that I am using to always get the next number? Okay, so putting up your hand, what's the rule going on here? Or maybe I'll just ask someone randomly here. Let's go with Scott. What's the rule? So we're just adding 3, right? Okay, now more importantly, what is T6? Eric, what's T6? Oh, that's good. 18, right? Okay, what is T7? Logan. 21. Okay. What does T7 mean? Jason. Yes, the 7th row or the 7th term. Good. Okay. Again, it's an efficient, quick way of writing the 7th row. Okay. And like I said, the complicated thing about mathematics is the simplicity in which it likes to write everything. Okay? It has a lot of symbols, has a lot of things that make it confusing. But once you kind of translate it, it's like, oh, that's not so bad. Okay, now let's go back to the same one, and let's talk about the number of triangles. So look at row 1. How many triangles here? 1. Okay. Row 2, how many triangles? 3. Okay. Row 3, how many triangles? Okay. Now whenever you're doing a pattern, you have to do a minimum of 3 terms to get the pattern. Don't stop at 2. Because if I just gave you 1 and 2, what would the next number be? Huh? No, wouldn't be anything. Could be 3 or 4, right? How could it be 3 or 4? You could either be adding 1 every time, or you could be multiplying by 2. If I put this, all of the doubt is off. Okay? So you need 3 terms before you can make a generalization. So if you had a little picture with 2 of them done, take the time to draw the third. Okay? If you're taking shortcuts to get to the wrong answer, that's extremely inefficient. You see that? There has to be that fine line between, I think I got to do a little work to be efficient. But people who skip steps to get to the wrong answer faster, that's the hugest waste of time ever, because you get the same mark as someone that didn't even spend a second on it. Okay? Now, what do you think is the next number after 5? 7, and then, okay, what would T6 be? 11, and T7, would be, okay, so what would be our rule here? Add 2, right? Okay, this one's fun. Let's do Pascal's triangle. Okay, so here's row 1. There it is. There's row 2. That's row 3. And that's row 4. Okay? Now, this one says, well, what is the sum of the numbers in a row? So all you do is you take this, and you add it to nothing, because there's nothing else. So that's 1. If you take this row, 1 plus 1 is 2. If you take this row, 1 plus 2 plus 1 is 4. If you take this row, 1 plus 3 is 4. Plus 4 is 8. Okay, what do you think would be the next one? 16, 32. Okay, you may recognize this one. Okay, what's the rule going on here? Times by 2. Okay, now the fun question, who here, again, please put up your hand, could give me the 5th row? Who can see patterns to give the 5th row? No, we didn't. We found the sum using our pattern. But I'm asking, what is the 5th row? What does it look like? Yeah? 1, 4, 6, 4, 1. Okay, next example. Just kidding. Okay. Now, what happens in a group, and it depends on which example, eh? But you get a few people, then a few people more. Don't give it away. Don't give it away. Let them figure it out. Okay? Now, who wants to give you the next row? Yep. Okay. Now, there's still people in here going, what's you getting at? Okay? So, this is how you get it. You'd always drop a 1, and then you just take these and add them together to get the next one. Okay? Now, that's where you got to look at the row above, look at the row above. Like, if I just gave you 2 rows, I bet you would not come up with the other rows. But after 3 rows, and definitely 4, you would be able to, right? Okay, so what would T8 be? What would be the sum of it? 128, okay? and T9 would be 256. Okay, so what you did on that puzzle yesterday, you're going to have to do a lot. Okay? Now this one, you got a triangle, and the triangle says, or the question says, each triangle is 32 centimeters. Each side of the triangle is 32 centimeters. So what is, if I went and took the triangle and I cut it in half in each one, right? Hence diagram 2, what would be the length of each side of those triangles? These would all be 16s, right? Because I cut each of them in half, right? Now, in this new triangle here, what would you expect all the sides of all these the new little triangles to be? 8, right? These will all be like 8s. Okay, now if I was to draw this again, what do you think all the lengths would be? Those would be all 4s. Okay, now I got to draw this, the 4s in there. And what do you think all the little guys inside the next one would be? 2s. Okay? So if I go to my table, it was going 32, 16, 8, 4, 2. Okay? Now, see if you know what I'm looking for here, because I've already... What is the rule? Okay, putting up your hand, what is the rule? Yep. No. Yep. Multiply by a half. When do we divide? Never. You're in every one of these, will we be multiplying or adding? Now, how on earth can you get less and less and less by adding? You know, add a negative. Adding negatives makes things smaller, okay? So we will always be multiplying by fractions to make things smaller or adding negatives to make things smaller, okay? Again, little things that you can write yourself on your study sheet or whatever so you're not falling in the trap, because you can see our formulas are always have times r, times r. What's r? That multiplier, not a divider, okay? And you always multiply by fractions to make things smaller. Now in the first diagram, there was one triangle. Okay, so I'm going to erase this quick. So this had one triangle. This had 5. What? 1, 2, 3, 4. And the original would be 5, right? So we got 1, we got 5. How many triangles in diagram 3? Okay, so that's a pretty solid pattern. So what would be the other two? 13 and 17. Okay, and the rule? Add 4, right? Okay. The mean daily temperature in Calgary. The guy who wrote this book lives in Calgary. On January 1st, 8 degrees Celsius. For the next 10 days, the mean daily temperature decreased by 4 degrees Celsius each day. So what would the first day was 8. What was the second day? 4, and then 0, then -4. The rule? Yeah, add -4. So that kind of, I've displayed already how we're not going to subtract and we're not going to divide. Okay? So will that come up on a quiz? Who knows? But if you have it written on your study sheet, and I asked that on a quiz, you should get it right. Okay, now, it says the row will always consist of natural numbers. Does anybody know why 1, 2, 3, 4 are called natural numbers? It has no decimals. They're positive. They're natural because those are the first numbers you ever used. Okay? So we actually naturally learn the natural numbers system first. What is the next thing that little children learn after they learn their natural numbers? No, because those are still natural numbers. No, not yet. You don't. No, don't know. Don't get fractions in there. Stress your kids out, man. See, and a lot of you don't know this, but the next thing that you learned was what 0 was. Now, do you know that you cannot teach 0 until you teach what 1, 2, and 3 are? If you have 3 balloons and a really sharp object, you can show them what 0 is. They will cry, but it's a harsh world out there. They better learn it now, okay? So when you take them all away and you go, okay, how many balloons do we have now? Right? And then they kind of wipe their tears and like, okay, we're doing math, so I'm excited. So they're like 0, right? So they really understand 0 once they know, but don't start teaching 0 right from the beginning. You don't say, okay, how many apples are there? What are you talking about? There's no apples. This is stupid. I hate this game. No, come on, tell me how many apples there are, right? So you got to do the 1, 2, 3, and then you can start taking things away and teach them 0. I was actually in teacher convention, and it was like math games, and I'm like, hey, I like math games, right? So I'm in this, and it's like lots of people in there, and I'm like in the middle, and I look around, I'm like the only guy in there. I'm like, this is weird. Like, oh, guys don't like math games, because I didn't read the whole thing, and it was math games for kindergarten teachers, right? So I'm like, oh no, and I'm stuck in there. I'm like, hey, oh, right? And they're showing how that they have this magnetic thing, and they put 6 butterflies on there, or sorry, ladybugs. They're magnetic ladybugs, right? And what they do is they get the kids, so they're kindergarten, right? So they get the kids to count how many there are, right? So you put 6 ladybugs on there, and you get them to count. And then what you do is you take those ladybugs and you slide them down to the bottom corner, right? And then you go to the kids, you go, how many ladybugs? And they're like, oh, I don't know, right? So you count them again. 1, 2, up to 6, right? And the kids are going, oh, what a coincidence, right? So then moves them again and says, so how many ladybugs now? And there's a couple kids going, I know, no, don't tell yet. And other kids are going, I don't know, right? So if you first have to learn that if you have 6 things and you move them somewhere else, how many things do you have? See, someone spent a lot of arduous time with you guys in kindergarten to get where you are now, right? And you have no idea how you had to learn that before you could learn 0 or you could learn, because some kids in kindergarten are like, well, I didn't know if you moved it, you had the same amount. Okay, well now I do. Okay, good. Got on my study sheet. But, so I'm sitting there going, wow, like I really appreciated as a high school math teacher what somebody did to get you guys where you are, right? Because you guys are probably pretty good at your like ladybugs and stuff, eh? Right? I mean, you can build a cocky boat. Oh, pretty awesome. You can move those around. I got it. But anyway, that's where you started. So you didn't even go with 0 yet. You don't be taking ladybugs off at this point, okay? A few kids dropping out of kindergarten right away because they're scared, right? So you just move them around. Now, so the next thing you learn is 0, 1, 2, 3, 5, 6, 7, 8, 9, 10, which is which set of numbers? Whole numbers. Then you learn integers, negatives. Okay? Now, in this one, these will always be natural numbers. You will never have, give me the 8.24 fifth row. Okay? They'll all be natural numbers. I don't even want the 0th row, because that doesn't make sense, does it? Right? So 1 to infinity rows. Now, the number of cards will sometimes, cards is not a good example, but pizzas, number of pizzas in that row, you can have 2.5 pizzas. Now, 2.5 cards, that doesn't make sense. 2.5 coins. Okay, so you even have to look at what are they talking about. Okay? And I have the old notes, but yours is probably right. This says T2 is 6, right? And T3 is 9. Okay? Okay, let's go to the next page. We're going to go right down here. Now there's arithmetic sequences, geometric sequences, and other. Does anybody know what arithmetic is? A lot of people think it's math. It's not. Arithmetic is just adding and subtracting. That's it. So arithmetic sequences for us is just adding. Okay? We're not going to say the word subtract. It's going to be like a dirty word in here. And geometric sequences, you're always multiplying. Okay? Now, whenever you graph an arithmetic sequence, so just draw a little graph quick, it will always be a straight line. So it can be going up, or it could be going down, whatever. But arithmetic sequences, when you graph them, they always make a straight line. Geometric sequences, that was like growth and stuff like that. Geometric sequences, what type of graph do they always produce? A curve, right. So it will look something like this, or it could decay like something like that, right? It can also come down. So it will always be what is called either nonlinear or a curve, okay? See? Things to know. Arithmetic sequences are always adding, produce a straight line graph. These are things to get on your study sheets, guys. Geometric, always multiplying by a constant term. Give me a nonlinear. Okay? Now there's kind of other things we need to know about these as well. Every sequence can be finite or infinite. To be definite or finite means I'm done, I'm ending. See, look here. It is saying I am not going on. But to be infinite, I will use this. And the only difference over here is this. And sometimes I can even put a period here to end my sentence. But ... means keep going. Infinite, I think we kind of know that one, right? It's going on forever. But in mathematics, infinite will either be like the 8 on its side or ... That's what infinite always means. Okay. Next, just a go 2 pages actually. So this is just circle the word. A sequence in which the next term is determined by adding a constant is called arithmetic, and will always produce what type of graph or function? Linear. Okay, so you can put the word graph there. And a sequence in which the next term is determined by multiplying the previous term by a constant term is called geometric, and it will always produce a non-linear graph or function. And you can even put in curve to be more specific. Okay, so you're doing questions 1 to 15, omit 8, 13, 14, 15, and the group activity. Now, for those people that don't know what omit means, it means do it twice. Okay, so just write that down. Now, just as a precaution, after you write those down, I would go to the pages and actually cross them out. Okay? Because you know what happens? You're doing 1, 2, 3, 4, you're cruising, 5, 6, 7, you're cruising, you're doing 8. You get stuck halfway through 8. You come up and you're like, I don't get how to do it. And I'm like, the question that I said to omit, you're like, oh, crap, right? And then you sit down and you've wasted time doing a question that I took off because it's not a good question anyway. Okay? So you don't even want to waste some time. You want to get right to it, finish all your homework in class. Just so you know, for today, if you go 1, 2, 3, 4 pages, 5 pages, 6 pages, okay, 7 pages, that's long, 8 pages, oh, no, just a minute, 7 pages, what happened, where's my, must be at the top here, what happened? Yeah, Yeah, mine was gone, eh? Okay, so I missed that page. But anyway, page 13 is your answer key. Now, just like I promised you, I guess I should go back to the beginning of this one. Now, if you're at home right now, which none of you are, but what I do is I just scroll through the assignment like this. And this may seem kind of fast to scroll through, but you have a pause button at home. So you can just pause, and then you can still do the questions, right? So you know all the notes now. You know the exact homework to do. You have all the answers. Well, because you could go to my website and have the answers. Now, for you guys on Tuesday, starting Tuesday, you have two options. You can this weekend go to my website and print out the answers for each one, which might be a bit time consuming, or borrow a tablet or whatever. Also remember that there's like 100 of you-ish in Math 20, 32 of you in here right now, so it means about 60 of you, 60-ish, are out in without needing a calculator maybe, or their iPad or whatever, so you can always set that up, right?